The human body is an engineering wonder, but change is a constant in nature. As our bodies age, they change. The technologies to repair or replace parts of our bodies change too. Over time, orthopedic implants have evolved from bone to metal to polymer as scientists search for the strongest and most compatible solution. Today, a remarkable innovation has taken this evolution full circle to a material made from elements naturally found in the human body, one that's as strong or stronger than bone, is biologically kind, and is bone-like in imaging. This material is Amedica's silicon nitride, and it's not just a vision, it's a reality, with a full line of spine products already in use today. Silicon nitride is widely recognized for its exceptional strength in key NASA shuttle components, jet engines, and body armor. Because it's made from elements already in the human body, scientists believe it would make a more compatible human implant material than PEEK polymer or metal. Several of the world's top ceramists spent years proving this theory. Today, their efforts have paid off.
Ceramics give you the opportunity to provide a material with high strength, high reliability, wear resistance, the ability to have artifact-free imaging, and the ability to bond to bone, uniquely combined in one single material.
It is strong, it is wear resistant, it is tough, and it has this interesting feature of being very biocompatible.
We now have a medical-grade silicon nitride that is not only natural, it's inert. It has a textured and hydrophilic surface so that bone will grow to it. It's 20 times stronger than PEEK, and it doesn't vary in quality.
Silicon nitride appears to have a lot of the qualities that you would want for clinical success. It has the advantages of surface chemistry, the ability to have bone attached to it, and a similar chemistry and an atomic number to bone. PEEK has none of that. It doesn't have the surface chemistry, and so therefore there's not an attachment by the bone, an osseointegration.
Silicon nitride is a new material that we've been working on for over 12 years. It has a long history in manufacturing, but just not in the medical device arena. It is lightweight, it is stronger than any ceramic that we've ever used in orthopedics, and I think it will be a life-changing material when we use it in hip replacement.
Never in the history of orthopedics and spine has there been one single material with this wide range of capabilities.
Silicon nitride also has the unique distinction of being visible in all types of imaging: X-ray, fluoro, CT, and MRI. Yet it doesn't cause obstruction or leave artifacts like metal. These are huge advantages for post-op implant interface assessment, as well as intraoperative implant placement.
People are clamoring for a better, newer, hard-on-hard surface. The metal-on-metal parts have not had a very good track record because of the ions that are released with wear, and that's never been a problem with ceramic-on-ceramic. So ceramic-on-ceramic doesn't give off ions, it's extremely biocompatible, and as I said, it's extremely strong.
Amedica has 12 issued patents and 20 pending patents on the use of silicon nitride in medical applications, and manufactures it in 3 unique forms required by the body. Amedica is the only company in the world with FDA and European Union clearance to use silicon nitride in medical applications. The company's microcomposite, or MC², has FDA clearance for use as an interbody fusion device. It provides the foundation for Amedica's spinal products, including spacers, fusion hardware, biologics, and minimally invasive solutions.
I have patients now that are over a year out, and I've had excellent results. We see good bony ingrowth, patients feel very good. The surgeries went smooth, the healing went smooth, the radiographic interpretation of how they are a year later is exactly as we would want them, with progressive bony fusion, no loosening, and a solid clinical outcome.
But that's just the tip of the iceberg. Polished microcomposite ceramic, with its diamond-like strength and appearance, clearly has the potential to revolutionize the total joint replacement market. And their porous cancella structured ceramic is ideally suited for inner body fusions, as well as hip, knee, and total disc replacements.
But we also see in the future that this could have great application in reconstructive surgery for hips and knees and other areas where, again, biocompatibility and strength, surface finish, and toughness are important elements for those particular medical devices.
So when we first started talking about silicon nitride, what was very unique about this substance was that you could make it into a porous structure that bone could grow right into, or you could make it into a very smooth structure that could be a bearing surface with virtually no wear. And the same substance could be both sides of that. You could have bony ingrowth on one side and no wear on the other side of an articulating spacer. And that was what sort of started our excitement about this. And from that sort of genesis, we realized we could create fusion products that we use not that need a bearing surface, but need two bony ingrowth surfaces, so that we could use that material to create what we don't have with the other materials today. That is a strong structural support, yet perfectly formed to allow bone to grow right into and through it.
All three types of medical-grade silicon nitride ceramic are produced in Amedica's one-of-a-kind manufacturing plant, the only facility in the world manufacturing medical-grade silicon nitride ceramic implants. In medicine, the standard of care is continually changing to keep up with our changing population. Today's orthopedic implant patients are younger, yet living longer. They want solutions that will last longer too. From bone to metal to plastic, and now silicon nitride, the evolution is complete, but the possibilities are endless. Amedica. Rethink what's possible in spine and reconstructive surgery.